Hello guys, thank you for using the asset. Here I opened an empty project and imported the asset here. First of all, let's look at the files that we have in the project. First of all, it's an instruction with detailed explanation of how to use this asset. Also, we have some demo assets used in the demo scene and in this tutorial. Then we have some Python notebooks with examples of model training. You can use it after you make a Markdown here. Also, the prefabs. They contain a main camera. It's a predefined camera with post-processing added. Also, the prefab for object detection with post-processing, object detection with rotation, and segmentation asset. Then we have some scenes and also a demo scene where we have configured Markdown pipeline, so we can run the project and make the Markdown for segmentation. If you want, for example, object detection, you can disable this game object and enable the game object for rotation, for example. So let's look how it works. We just turn the segmentation on, run the project, wait a few seconds. So after Markdown is finished, so I stopped the project and the generated Markdown is saved in the following path. You can look at the output path display component and take the path from here. So make sure that the YOLO version selected in the Markdown component is the same as in output path display component. Also, you can output the path to the console or just copy it from this field, from full output path field. So let's open this path. Here we have the generated synthetic dataset. We have test folder with images. It's the generated images. Labels. It's text labels used for YOLO model Markdown. And also we have labeled folder where we can see the visualized bounding boxes. In such case, we have segmentation bounding boxes. So now let's return to our sample scene and let's set up everything from scratch. First of all, we can go to demo assets and choose some asset for object detection. For example, select this cone. First of all, of course, you can use any object. You can use your own objects that you imported. So first of all, make sure that the object has a mesh renderer component and also a tag. Here we can see that the cone is untagged, so just select some tag, and this tag will be used as a YOLO class in the Markdown. Of course, you can add other tags. Go to tags and layers menu and just type anything you want. So let's return to our scene. As you can see, in the default Unity scene we have a main camera, but this main camera doesn't have post-processing components, so just remove it and use main camera from the prefabs folder in the project panel. So as you can see, this camera has post-processing settings that we need to modify post-processing from our scripts. So let's start with the synthetic Markdown objects. Let's start with, for example, object detection with rotation. Let's drag and drop this object to the hierarchy window. First of all, we need to drag and drop capture camera here. Let's use our main camera. Then drag and drop scene light. For example, we can use directional light. And after that, we need to add objects to render. You can add multiple objects, but as soon as we have only a cone, let's drag and drop it in this field. Then you can select the base output folder, YOLO version. You can select from 8 to 11. And then select the train test validate percentage. Select number of images. For example, we can select any number, for example 50, and then image width and height. Here is important note, we can make sure that image width and height match with the main camera, with the game view width and height. As you can see, the width and height currently is 720, so if we want to use 640, we must select the appropriate game view window size. Also, as you can see, our main camera looks in an arbitrary direction, so we must set up a camera so it will see our cone. We can just click the main camera, then game object, and align with view. And now we see our cone. So let's continue with our setup. Also, you can use additional augmentations, for example, add Gaussian noise, motion blur, and other augmentations. Also, you can randomize light. Let's select it, and you can generate 360 degrees rotations. You can select angle. For example, let's select 30 degrees, and you can select axis. Around this axis, the object will be rotated. Also, you have isolate each object checkbox. It is used if you have multiple objects on the scene and you wish to make rotations for every object. So now everything is ready. Make sure that object detection with rotation game object is active, and just run the project and wait a few seconds depending on your computer performance. So now everything is ready, and now we can use output path display component to see our generated dataset. So let's copy paste the path. Here we can see the following files. First of all, data YAML. This file is required for YOLO model training. Also, we have images folder, split it into test, train, and validate. And you can see the object with different rotations. As far as you remember, we added Gaussian noise and lightning and light variations, so the background is always different. Also, as you can see, we initially we selected 50 images, but as soon as we selected generate 340 rotations and selected 30 degrees angle, the generated data set contains only 11 images. So if you unselect this checkbox, there will be 50 images as we initially selected. Also we have labels, also split it in test, train, and validate, and we have the YOLO, the Markdown in YOLO format, and also we have labeled images. It's just for the visualization of the bounding boxes. Now let's try a different axis. Let's try y-axis and run the project. Let's go to our dataset folder, and now as you can see, the object is rotated around the y-axis. So now let's experiment with another game object. It's object detection with post-processing. So I will disable object detection with rotation and use object detection with post-processing game object. Let's add some new. Let's add some more objects to the scene. I will go to the demo assets, vehicles, and select ambulance car and, for example, a tractor. So first of all, we need to set up our game object. As in previous case, let's add a capture camera. Let's add a scene light. Now let's set up the image width and height. Now let's choose different size. For example, 1240. Of course, we must set the appropriate size in the game window view. Let's adjust the main camera. So click main camera, game object, align with view, and maybe increase it a bit. Now let's add the objects to our object detection with post-processing. First of all, add our cone. Then we should add ambulance, but as you can see, the parent ambulance game object it hasn't any mesh renderer, so we need to use child object, for example body, for this purpose. And the same thing for the tractor. Also we need to add appropriate tag, so we choose ambulance for ambulance and tractor for the tractor. And now we can add some post-processing. For example, we can add motion blur. Also we can randomize depth of field, randomize chromatic aberration, also color grading and grain, for example. Also don't forget to set up post-processing volume. We can select it from here and use post-processing volume from the main camera. Now everything is ready, and let's generate our dataset. Now dataset generation is ready. By the way, we will have a message in the console that dataset generation is complete. And now use output path display component to show the generated data. as you can see, we have data YAML. Now it has 3 classes: cone, ambulance, and tractor, and pass for the Markdown. Let's see the training folder. As usual, we have images, and we see that the post-processing is applied. We can see that colors changed, there are grain, some Gaussian blur. Also, we have another effects, but they are a bit weak, for example, motion blur. And we can tune and tweak it here in the inspector. And let's see the bounding boxes. So you can see them also in here, and the appropriate labels. As you can see, bounding box around the tractor is a bit smaller than the tractor itself, because we used a body for object detection, not the entire tractor. Because entire tractor consists of shovel, body, and wheels, and we used just body game object for object detection, so we have a bit smaller bounding box. So let's look at the labels. They also contain numbers with format for appropriate for YOLO model training. Now let's try some more examples. For example, imagine that we need only training dataset, so we will put here 100, and also we don't need any effects, despite just one effect, for example, random crop. So maybe we need 100 images. Let's run the project and wait for the dataset generation. So the dataset generation is complete. Let's look what we have. Let's look at the training folder. We see that the random image crop is applied, and we get quite diverse dataset. Also, I forgot to uncheck the motion blur checkbox, so sometimes we can see that the motion blur is also applied, and we have slightly blurred images. But we can also turn this checkbox off, and we will get only a random crop. By the way, if you want to reset the settings, you can press Reset Settings button, and now everything is returned to the original state. Let's move on. Let's try to use segmentation game object. This game object can make segmentation datasets, so they may be used to train YOLO segmentation models. So as usual, we can add capture camera, so our main camera, add directional light, and let's add our game objects. So it's a cone, ambulance, and tractor. Let's double check that the tag and mesh renderer are there. Let's disable object detection with post-processing game object, because now we need only segmentation. We can select YOLO version, for example YOLO V 11, and also we should select the same version in the output path display component. Let's stick with our current image size. It's 1240, so select it also here in the component. Also we can choose dataset split. Let's leave it default. Also we have some minor post-processing effects here, but now I don't use it. And now everything is ready and we can run our project. So the dataset generation is complete. We can see the following message in the console. Now let's stop the project and go to the to our dataset folder. Now we have, as usual, data YAML with our classes, and let's see the labeled images. Now the labels contain not only the rectangular bounding boxes, but they have multiple vertices, so we have a segment. Basically it's a segment for segmentation task, and we can use this data for YOLO model training. So YOLO will use these images and also these labels. As you can see, these labels have much more numbers than object detection, because here we have full segment vertices. So I have showed you how to use object detection and segmentation components, how to make synthetic datasets using the asset. Now let's briefly talk about model training. I have a folder called model training here, and I have example of Python notebook for object detection and object segmentation. Let's start with object detection. So here I have a simple notebook for basic model training. It was inspired by the notebooks published by the RoboFlow company. I give a reference below. So first of all, we check the GPU here, and then we unzip our dataset generated in Unity. So, for example, let's look at the object detection dataset. Let's go to the appropriate folder, and you can see that we have file structure with the dataset that we generated. We can go up one level, and then we can rename this folder as dataset and compress this folder as a zip archive. And then we can use this archive for the model training. We can upload this archive to our project, for example in the Google Colab environment, and then we can unzip it here. After that, we just define the home directory path. Also we install the dependencies, and then we start model training. So task is object detection, mode is training, and also we select some basic hyperparameters such as 50 epochs and the image size. Make sure that this image size is the same as selected for the dataset here, as image width and image height properties in the component. After model training, we can see some basic metrics, for example, confusion matrix and other metrics. And we can also output a random batch from the dataset. Also, we can validate the model, and then we can try to make inference with the trained model. Here I used the sample image, and we can see the result here. We can see that the fire truck is detected well, but the police car and cone not so good. It's because I used only about 50 images for model training. So if you use 1000 images, the model will work as intended. That's all. You can use, as I said, for example, collab environment, and you can use this notebook, upload it to the Google Colab, add the dataset archive, and just train your model. Now let's move on to the object segmentation. I have also the demo notebook. Generally, it's almost the same as object detection. We also use dataset, but now we use dataset for object segmentation. So we can go here, copy the path, open it, and rename it to the dataset, and make an archive. So, and then we can upload this archive directly to the collab environment and unzip it here from the Python script. Then we train the model, but now we select the segment task instead of detection task, and also choose some hyperparameters. Also, we have some metrics. Here we can see that we have the polygons for the objects instead of just bounding boxes, because it's a segmentation task. And the same way we can validate the model and then use it for object segmentation. Speaking about Python notebooks, here in the instruction we have point 4, working with object detection, and at the bottom there is a link to the notebook in Google Colab. You can just copy it and use for your model training. And similar thing is for segmentation notebook. Here is the link. The code here is just the same as in files in the asset, but you can directly copy it and run in your environment. The last thing I want to say is, again, thank you guys for using this asset. Also, a few important notes. Please, if you work with these objects, don't forget to add mesh renderer and tags to the objects, and also please set the game view size the same as image width and height in the component, so the scripts will work as intended. Also in the package you have all the scripts in the scripts folder, so if you wish to modify something you can do it here. But also if you find any bugs or want to add another features, please contact me with the email. It is given here below in the instruction, and I will answer you and try to fix bugs or do the improvements as soon as possible. Thank you very much, guys. Goodbye.